and in this video we are going to find the transfer function using converting this block diagram to signal flow graph, then find the transfer function. So convert the given block diagram to signal flow graph and determine C of S divided by R of S, that is transfer function of the system. So first step is we have to convert this block diagram to signal flow graph. So for that we consider the points, and this is 1 means, and this is 2, and this is 3, and this is 4, and this is 5, and this is 6. So make like points like this. So this one is 1. So make a point like this 1, 2, and this 3, and this 4, and this 5, and this 6. So totally we have 6 points here. So the next step, and this is 1 to 2, here no gain, so this is given as 1, and for 1 to 3 also there is no value, that is given as 1, and 3 to 4 we have, and this is 3, and 3 to 4, this is 4 means we have G1 block, and 4 to 5, and this is 5 means we have G2, and 5 to 6 no value, that is 6, this is 1. Now we are going to define the loops. So 4 to 2, so 4 to 2 we have a loop with minus symbol, so this become minus H. And from 3 to 5, we have a loop again, this also with minus, and this is a path, forward path with minus symbol. So 3 to 5 we have minus G3. So this is the conversion of block diagram to signal flow graph. So now we convert this block diagram to signal flow graph. So this is the conversion of given block diagram. So we convert that block diagram to signal flow graph. Now next we have to find the forward path gain, because the transfer function formula here is 1 by del summation of k pk del k, and here this forward path, there are 2 forward path. So one is this one is the forward path 1, and this one is the forward path 2. So this one is forward path 1, and this one is forward path 2. So there are 2 forward path, and there will be a 2 forward path gain, P1 and P2. So we have to find first P1 and P2. So gain of forward path 1, that is equal to G1 into G2. All are remaining, all are 1. So the forward path gain is the multiplication of each gain. So that is G1 and G2. And in forward path 2, the gain is minus G3 only. So the gain of forward path 1, that is equal to G1 G2, and forward path 2 is equal to minus G3. So next step is individual loop gain. There is only one individual loop. So this individual loop. So the loop gain is this 1, G1 and H. So the loop gain of individual loop 1, that is P11 is equal to minus G1H, And next step is gain product of 2 non-touching loops. There is no combination of non-touching loops, so no need to find this gain product of 2 non-touching loops. Next one is calculation of del and del k. And del is equal to 1 minus sum of individual loop gain, sum of individual loop gain, and 1 minus, here only one loop gain, P11. So the value of this P11 is minus G1H. So putting that value in this equation, it become 1 plus G1H. So since there are no part of graph which is non-touching with forward path 1 and forward path 2, del 1 and del 2 is taken as 1 value. So in this step we found del and del k. And the transfer function, the mentioned again formula here is 1 by del summation of k pk del k, and here k is equal to 2, So this equation become 1 by del P1 del 1 plus P2 del 2. And P1 value we know G1 G2, P2 value is minus G3. So P and del 1 del 2 are 1. So this P1 value is G1 G2 minus this P2 value is G3 divided by del value is 1 plus G1H divided by 1 plus G1H. So now we found the transfer function of that given block diagram by converting that block diagram to signal flow graph.